down that there was like 30 people in line to check out from the hotel. So hopefully that's where everyone is. I'd like to thank all of you for gutting it out to day 3 of the 2019 annual LEAG meeting. Today is going to be a different sort of day from yesterday. Yesterday we talked mainly about the initiative to get humans to the moon by 2024 and our precursor missions. But today is about sort of what I alluded to yesterday, that we need to turn the moon from a wilderness, visited only briefly and tentatively, to a frontier of human activity. And turns out we've done this before, and we have a lot of thought about it. The Vice President and the Space Council have made it very perfectly crystal clear that we are to look at the moon as being a target for sustainable lunar exploration, building to permanence by 2028, with weeks, months, and even years on the surface of the moon. And in 2007, we had a NAC Tempe workshop organized by the NASA Advisory Council. And as it happens, we never actually went back to the moon. So most of the stuff in the NAC Tempe workshop remains pretty darn good. And another thing I'd like to point out is that LEAG tends to be operated and is predominantly composed of planetary scientists. To us, field science is very important. But there's other communities out there that have interesting and valuable things to do. And at NASA, we literally have meetings on a disturbingly regular basis about what does sustainability mean. And I would contend that what it actually means is you derive a broad multi-stakeholder community that derives value from the immense value of the moon. So when we get to a point when we have a permanent field station on lunar surface, where we have people doing research in material science, astronomy, heliophysics, biology, life sciences, it becomes a more sustainable endeavor and ultimately a more productive one as we bring the moon into Earth's economic sphere. So that's what all today is going to be talking about. Mark Robinson is going to give us a rundown on what happened with the Tempe workshop. And then we're going to start, I'm very cognizant of how we need to reach out to other user communities. So we made a real effort to bring them here. And we welcome you, and we'd like you to continue coming to these meetings because we're all in this together. And before I get off the stage and let Mark Robinson kick things off, I'd like to remind all the Hawk and Taylor Award winners we struck out yesterday. So meet me at 11 a.m. in front of the registration desk so we can take a freaking picture with all of you. So thank you. So Mark?
Thank you. What if they're gone by then? Okay. All right, thank you, Sam. I know these controls are complicated because everybody keeps saying funny things about them, so I don't know if I'll be able to figure them out. So here is the Lunar Science Workshop. It's a hardbound volume. Brad reports that there's still hard copies left. Is that correct? 2, okay. Maybe there's a box of them at NASA headquarters or something. However, it's also on CD-ROM, as well as the 127 or however many they were white papers, although probably a lot of you don't even know what a CD-ROM is, I guess, right? Because there's very young faces out there. However, if you Google it, there you go. You can find, and I just tested it. It's on the LPI webpage, the actual report itself, as well as all the white papers. So I encourage everybody who's getting geared up to write white papers to make sure you aren't rewriting a white paper that's already in the LPI archive. And you could probably enlist some of the people who wrote those and at least get permission to plagiarize large sections of the text out of that to drop into your white paper. Okay, Sam already gave a general overview of the Tempe workshop, did a really good job of it, so it makes my job a little bit easier. It was held in February through March, and that time frame is really beautiful weather in Tempe as opposed to the summertime. It was chaired by Brad Jolliffe and vice chaired by Clive Neal, and it was a very exciting time and a very exciting meeting because at that point we were all totally convinced that we were going back to the moon, and it was going to happen. So, all right, how do I? Can you guys just change the slide? Okay, the workshop was organized by a committee consisting of representatives from each of the NAC science subcommittees, the astrophysics, earth science, heliophysics, planetary protection, and planetary science. And as Sam mentioned, you know, it was a huge effort to get a very holistic science community together to understand, given the constraints that we had at the time, of what could be done on the moon during that early period of our return to the moon. Let's see, and there were about 250 attendees there, and there were about 75 of those folks gave presentations on their areas of expertise. Okay, I'll just be brave and try to do this and see what happens. Oh, cool. Okay, and of course, here's the key constraint or the key premise, was that the return to the moon architecture at that time was based on an outpost concept. Previous to that, there had been a big debate about sortie missions, i.e. like Apollo-style missions, versus an outpost. An outpost was a settled thing at the time. So the assessments were made with respect to the notional polar outpost location, but the attendees understood that the polar location and the sequence of missions to establish such an outpost were not set in stone at the time. So it was kind of a final call for inputs to modify or change that paradigm. And as I mentioned, sortie missions to other locations were not ruled out, but they seemed highly unlikely at the time, at least in the initial stages of a return to the moon. There was always talk about, you know, continuing on after we had the outpost. Okay, here's our notional polar landing site on the rim of Shackleton Crater. So at that point in time, it was pretty much notional and engineering, drawing, imagination, whereas now we actually have many observations of the polar areas in terms of lighting maps, imagery, and topography, so we can make really detailed assessments of lighting conditions, traversability, hazards, so on and so forth. So a lot has changed since the Tempe report. So a little bit of background. I think Sam and I have covered that to some degree, but it was called for to get scientific community through the NASA Advisory Council to feed into the administrator at the time was Michael Griffin. And of course, it was all about what science can we do on the moon as part of the vision for space exploration. The key issue for the science community was to determine the highest priority science activities. And that's one of the really, I think, important aspects of this report is the science activities are ranked in the back. And I think there's actually two rankings, if I remember correctly, the LEAG, and then what was the other one, do you guys recall? It's been 10 years. Anyways, there's rankings, science rankings in the back, and that's really something I don't think we've really talked about at this meeting is putting ranks on science activities. Yeah, and of course there were, you know, you get 200 scientists and engineers together, and there were a lot of suggestions to changes to the architecture and what things can be done to promote better science. It was really quite a fantastic environment. So the overarching goals was to ensure that NASA's exploration strategy, architecture, and hardware development enable the best and appropriately integrated science activities in association with the return of humans to the moon and subsequent exploration of Mars. Even then, it was feed forward to Mars, so this is not anything new. Bring diverse constituencies together to hear, discuss, and assess science activities and priorities for science enabled by the exploration architecture. And identify the needed science programs and technology developments, which that has been, you know, obviously a common theme in the meeting in the last 2 days. Okay, as I mentioned, there were a lot of inputs. There was a report on the scientific context for the exploration of the moon, fondly known as the SCIM report. At that, if I remember correctly, at that stage, it was in draft form. Is that correct? I don't think it was finalized, but maybe it was. It had been finalized? Okay. The astrophysics enabled by the return to the moon workshop, which had preceded this workshop, Earth Science Decadal Survey, a lunar exploration white paper of the Field Exploration Analysis Team, fondly known as FEAT, and then of course 40 years of lunar science. Okay, I'll just briefly go over the findings of the different subcommittees. However, I encourage you to flip through the book because there's really detailed findings from each subcommittee, and what's the science rationale, and equally important, what measurements are needed and with what accuracy and precision to some degree so that we can answer the questions that are being posed. The far side is a radio quiet environment, ideally suited to radio astronomy. For the example that's cited in the summary is a 21 center emission from hydrogen records the formation of the first structure of the universe and the first luminous objects. And they also talked about future free-flying observatories far from Earth that may be enabled by lunar architecture assets. In other words, we want to build really, really big telescopes, and having a heavy launch vehicle and some sort of infrastructure in cislunar space may enable such large missions in the future. Okay, Earth science. Well, of course, the Earth is always in view of the lunar near side, and that provides a really stable platform for full disk and full spectrum long-term observations of the Earth's surface and atmosphere. So you could get time-dependent atmospheric composition, ecosystem monitoring, observations of changes in the polar caps and cryosphere, something that's even more important that we realize today, the vertical structure of the Earth's atmosphere, and of course, there's the Sun-Earth system as well as the Earth-Moon system. So we want to get observations of the influx and influence of solar variability on climate. Okay, since this is a planetary science audience, mostly, I believe, I have 2 slides on findings from planetary science. Southern Polar Outpost provides access to the South Pole Lake and Basin materials. Incredibly important topic. Wouldn't you agree, Brad? Yes. And of course, whatever polar materials happen to be there in the form of volatiles and other polar outposts, of course, will limit your science return because you're in one location as opposed to, the Apollo-style sortie missions going to different areas of the moon. So it was discussed extensively that mobility of some type from the outpost was seen as a crucial component, be it long-range rover or a human hopper type vehicle that could take astronauts, 1,000 kilometers away, robotic missions, so on and so forth. There was a lot of ideas bounced around. No, there were lots of robotic missions. Yeah. There was a topic of discussion, and there were many great ideas. The development of technologies and strategies to deploy and maintain a geophysical network. Imagine that. For a long duration, that was viewed as one of the highest priority, and I think it's still bubbled up as highest priority today. Return samples were viewed as core science return, and I think this meeting would agree with that completely. Look at that, there's a whole slide on return samples. Wanted to maximize the mass of a return capability. I believe that topic came up yesterday. Modernize sample documentation procedures. In other words, help the astronauts, give them the tools to much better record what they're sampling. In situ measurement and sample sorting to the down select return mass. We talked about that yesterday. That feeds into maximize the mass of return capability. Having crew expertise and training was seen as critical. In other words, I think those are code words for have geologists and geophysicists on the moon, as well as pilots. And it was also deemed important that anytime we have an orbital asset in orbit around the moon, well, an orbital asset is in orbit, right? To make sure that there was a equivalent of an Apollo sim bay. In other words, so that you could put instruments to look down and look up from the moon to take remote sensing observations, and also to deploy small satellites. Actually, for those of you who don't know, the first CubeSat really was during Apollo. Okay, support of the science community before and during human missions to maximize the science return. I mean, there's always a fear when we start gearing up to go to the moon that it's expensive. Well, that's not a fear, we know it's expensive, but the fear is that the science community funding takes a hit because they have to transfer that funds to pay for hardware and development of human systems. So I wanted to emphasize the point that if we're going to the moon and to maximize the science return, you need to have robust support for the science community before, during, and after human missions. Okay, findings from the Planetary Protection Subcommittee. Operations on the moon are not constrained by current planetary protection restrictions. And I believe that's still true. And thus it makes the moon an optimal location to establish the magnitude of forward contamination issues associated with human exploration. Oh, that's from the other room over there, okay. The lunar return could facilitate this studies by just testing of equipment and technologies. For example, spacesuit leakage, which is happened during Apollo. It wasn't an unknown thing. It's not a bad thing, but so we can study that and engineer the suits to be better to minimize leakage and also measure exactly what's coming out. And also, same goes for any habitats on the surface. By habitat, whether it be a lunar module equivalent or an outpost building itself. And of course, the polar samples will require special procedures to prevent contamination of whatever frozen volatile samples are brought back to the Earth. Okay, and then there was findings on cross-cutting issues. In other words, things that didn't seem to fit under any banner of the subcommittees. So there was a recommended trade studies for non-polar outpost locations. The reason that outpost was selected was, it was complicated, right? But there's nearly continuous solar power, I should say power, not polar, power at the poles, a benign thermal environment, which is, simplifies engineering, delta V access, and the likelihood of ore grade resources drove the decision for a polar site. Science activities enabled by lunar exploration should be evaluated and prioritized by the decadal survey and science road mapping processes. And I think NASA's done very well following up on that recommendation. The roles and capabilities of astronauts need to be clearly defined and supported early within the architecture development. For full mission success, many of the science objectives will necessarily require the involvement of a scientist astronaut serving as an integral part of the science experiment or as a field geologist. I cut and pasted that out and put it in there, quote unquote, because that is a theme throughout the report. It was deemed to be very important by the folks who put this together. Okay, the outreach committee, which was not a formal subcommittee, I believe, they threw in their thoughts too. The moon is a witness to 4.5 billion years of solar system history. Human exploration of the moon will contribute greatly to discovering the origins of the Earth and of humanity itself. The moon is a unique location from which to observe and analyze the ever-changing nature of the Earth, Sun, and universe. The moon is a fundamental stepping stone to the human exploration of Mars and the rest of the solar system. I don't think much of that has changed. Okay, here's my 2 cents worth after flipping through the report the last week. The Tempe report is an incredibly, I didn't write that in there, but I'm adding that to emphasize, is an incredibly robust document that has stood the test of time, and it's worth digging out and studying. Updates are needed, and I'm not saying that it's a done deal. Certainly in light of the last decade of lunar scientific and technological advances, findings in there like we need a high resolution gravity map, done, box checked, so on and so forth. But as LEAG and others move forward in the current return to the moon planning process, should consult the Tempe report, the SCIM report, the roadmap, etc., rather than reinventing the wheel. I don't think we're doing that, and I think that suggestion is being followed by many that we're actually consulting these documents. Although I would emphasize that for some reason the Tempe report seems to get ignored a lot, and maybe that's because it doesn't have like a cool acronym like SCIM report or LER, but that doesn't mean that it isn't an awesome document worth revisiting. I'll especially emphasize the fact that there's all these white papers that were attached to it and they're still available. You can get them off the CD-ROM if you have a copy of this on your shelf, or go to the LPI webpage and download them from there. And that's all I had to say. I don't think your mic is on.
Yeah, I'll just, now it's on.
Okay.
Thanks, Mark, for that great summary. And I just want to point out that Mark was on the NAC at the time, and when there was a lot of hand-wringing about where to have the meeting, Mark, in his typical way, said, oh, let's just do it in Tempe. I'll organize it. And then he did. I'm sure he regretted agreeing to do that because it was a huge amount of work. Anyway, I just wanted to emphasize that at that time, the chair of the NAC was none other than Jack Schmidt. And so there was he had a very firm conviction that if the science community didn't make it very clear what the objectives were, that science would not be well integrated into constellation. And so that was the real purpose, was to make sure that not only was science integrated, but it was done in some sensible way, and it was done with community-driven documents. And so it was a huge effort on the part of the community to provide all of this input. And I think that really helped constellation planners going forward in figuring out, oh, yeah, we need to have return capability for mass to bring back samples. Scientists still care about that, and here's why. So anyway, thank you. It was a great time.
Ben Bussey, NASA headquarters. As we announced yesterday, we're going to have a workshop next April, and I think the trick is going to be, it's very much focused on something like Tempe. I think the difference between now and then is science is better integrated into the current plan than it was 12 years ago. But certainly one of our challenges is going to be, as you said, not reinventing the wheel and revisiting what's changed. And I think getting better buy-in from the non-planetary folks. There's a perception, at least at headquarters, from the non-planetary divisions that the people who showed up were only the ones who were incredibly positive and keen. It didn't actually represent those communities. So one of the challenges we're going to have is the Helio and the Earth Science, is getting a breadth of people there, so it is bought in on.
Yeah, I've heard that complaint before, and I think that's sort of part of the culture of complaint that we live in the U.S. Because all those scientists had the opportunity to feed up their science into, the AGs and the science subcommittees, and the subcommittee people were there to aggregate that and put it into the report. So I've heard that complaint too, but I don't really know where that comes from.
Yeah, I'm not saying I agree with it, but the trick is going to be, if we want those divisions to pay for the instruments from those fields that fly, then we're going to have to make them realize that the people that showed up.
Make them feel more loved.
Yeah, exactly. That's the
Fair enough. Yeah, okay. And just so everybody knows, I didn't know, like right in front of us here, there's a little monitor that shows your slide and a countdown clock. I didn't even see it the whole time I was giving the talk. I'm like, there it is.
Modern technology.
Yeah.
Thanks, Mark.